Hello students, in Science 1 today we will revise Chapter 11 Reflection of Light. What is light? Light is an agent which gives us information about what is happening in our surroundings. Light is actually electromagnetic radiation in the wavelength range from 4 into 10 raised to minus 7 meters to 7 into 10 raised to minus 7 meters, which when incident on the eye causes the sensation of vision and enables us to see the objects around us. When light is incident on the surface of an object, in general, it is deflected in different directions. This is known as reflection of light. Light reflects differently from the various surfaces around us. Reflection from smooth, flat surfaces is called regular reflection, while that from rough surfaces is called irregular reflection. What is a mirror? A surface which reflects light and creates clear images is called a mirror. A mirror is a reflecting surface. A polished surface absorbs less light and so maximum light gets reflected. We use various types of mirrors in our daily life. Mirrors are of two types, plane mirror and spherical mirror. Plane mirror. What is a plane mirror? A mirror is made by coating the back surface of a flat and smooth glass piece with a thin reflecting film of aluminium or silver to protect this reflecting film and to make that side opaque. Another coat of a substance like lead oxide is given over it. A plane mirror is also called a silvered glass mirror. A German scientist, Justus von Liebig, made the first mirror. Laws of reflection. There are two laws of reflection. The first law is the incident ray and the reflected ray of light are on the opposite sides of the normal to the reflecting surface at the point of incidence, and all the three are in the same plane. The second law is the angle of incidence and the angle of reflection are equal in measure, where I is the angle of incidence and R is the angle of reflection. Therefore, angle I is equal to angle R. Characteristics of the image formed by a plane mirror. The image is virtual, erect, and is of the same size as that of the object. The perpendicular distance of the image from a plane mirror is equal to the perpendicular distance of the source from the mirror. Source here means object. Lateral inversion. Lateral inversion is essentially the result of image formation according to the laws of reflection. When a person stands in front of a plane mirror, the image formed is upright or erect and of the same size as a person and at the same distance of the person from the mirror, but his right hand side appears to be the left hand side or vice versa. That is, the left hand side appears to be the right hand side. This is called lateral inversion. Images formed by a mirror. There are two types of images formed by a mirror. The first is real image. An image formed by reflected or refracted rays of light at a point is called a real image. It can be obtained or projected on a screen. Virtual image. An image formed at a point from which the reflected or refracted rays of light appear to diverge is called a virtual image. It cannot be projected on a screen. Convergence of light. When light rays meet at a single point, it is called convergence of light. A converging beam of light is used by doctors to examine teeth and sensory organs. It is also used in solar devices. Divergence of light. When light rays from the same point source spread away or scatter away from each other, it is called divergence of light. A diverging beam of light is used in street lights and table lamps. How to calculate the angle if two plane mirrors are placed at various angles to each other. The formula used is n is equal to 360 degrees upon a minus 1, where n is equal to the number of images formed and a is the angle between the mirrors. On using the formula to calculate the number of images formed in two plane mirrors kept at various angles is as given below. We obtain the following result. For angle equal to 90 degrees as shown in the figure, n is equal to 3, that is the number of images formed is 3. For a is equal to 120 degrees, the number of images formed is 2. For a is equal to 60 degrees, the number of images formed is 5. For a is equal to 45 degrees, the number of images formed is 7. And for a is equal to 30 degrees, the number of images formed is 11. If the mirrors are kept parallel to each other, the number of images formed will be infinite. Spherical mirrors. There are two types of spherical mirrors, a concave mirror and a convex mirror. Concave mirror. If the inner surface of the spherical mirror is a reflecting surface, then it is called a concave mirror. Convex mirror. If the outer surface of the spherical mirror is a reflecting surface, then it is called a convex mirror. Let us revise the terms related to spherical mirrors. Pole. The center of the mirror surface is called a pole. P is the pole of the mirror as shown in the figure. Center of curvature. The center of the sphere of which the mirror is a part is called the center of curvature of the mirror. C is the center of curvature of the mirror as shown in the figure. Radius of curvature. The radius of the sphere of which the mirror is a part is called the radius of curvature of the mirror. That is from the center of curvature to the pole of the mirror or from the center of curvature to any point on the mirror. The length CP or CA in the figure is the radius of curvature of the mirror. Principal axis. The straight line passing through the pole and center of curvature of the mirror is called the principal axis. Here in the figure, PM is the principal axis of the mirror. Principal focus. Incident rays which are parallel to the principal axis of a concave mirror after reflection from the mirror meet at a particular point in front of the mirror on the principal axis. This point F is called the principal focus of the concave mirror. In the case of a convex mirror, incident rays parallel to the principal axis after reflection appear to come from a particular point behind the mirror, lying along the principal axis. This distance is called the principal focus of the convex mirror. The principal focus is represented by capital F. Focal length represented by small f. The distance between the pole of the mirror and the principal focus is called the focal length. This distance is half the radius of curvature of the mirror.